Today we're gonna test our experiment, which is separating mixture using condensation and evaporation. Okay, we have room temperature water and salt as the solute. Okay, this is our container and there is a cup, I see. Okay, this plastic cover will act as a place where condensation will take place. So we're gonna fill up the water with some salt, I guess. Okay. So the salt has been placed inside the water, so it will become a solution as we have a solute and a solvent. So we stir it well until all the salts are gone, dissolved inside the water. Salt has fully dissolved, so we're gonna put inside the container. I forgot to mention that this is a 250 ml water to start with. Okay, we're gonna put it outside. Unlike, as you can see, it's very bright, so the camera maybe can't see it directly. So this is how we're gonna set our experiment. Okay, now we're gonna play the waiting game, because although evaporation happens at all temperature, it still requires the water to change state into gas, so it needs to break bond. Okay, so we're gonna talk inside. Okay, the time is currently 11:50, so we're gonna wait for 2 hours at least, so the process will undergo smoothly, because condensation can take time based on the surrounding temperature. So we will see what will happen. Okay, condensation happens when gas turns into water. Where will the condensation happen? As you can see, I put the plastic cover, so when the gas rises, it will eventually cool down. When it cools down, it will turn back into water, or the absorption will become water droplets. So the water droplets will eventually slide down into the cup inside, and there we go, there's the pure water. So 1 hour from now, we will see the outcome of this experiment. Thank you, guys. So it's already 2 hours from our experiment, so I'm gonna show the result. So it has been 2 hours, and this is the water we have collected from this experiment. So as you can see, there's currently water droplets that are formed on our plastic cover. So how about a test to make sure there is no salt in this cup? Here's for pure water, I guess. So we try. Yeah, not salty and just tastes like pure water. So I think we have achieved the target of the experiment is to obtain pure water from a salt solution. So that's all from me. Thank you. Welcome back for our experiment. So today we're gonna test our experiment, which is red cabbage can be used as a substitute for litmus paper. or we say as an indicator. So we're gonna chop up first the red cabbage. Now we have chopped half of the cabbage, so we're gonna put some inside our mixer, blender, to have the red cabbage solution. So we just peel it off. So we have the red cabbage inside of the blender, so we're gonna put some water so it will blend properly. I'm using 2 cups of water for your information, so just blend it. Okay, have blend it and we have filtered. So this is some of the blended cabbage, I guess. So that is the solution we have been wanting for this experiment. So we're gonna test our experiment now. So pour it in different glasses, so we will not use waste of the solution. Okay, we have 3 glasses to use for the experiment. We have a lemon and we have magnesium sulfate to test. Behind the scenes, I have squeezed the lemon and make a magnesium sulfate solution. So if you're wondering, this is the packaging and this is the inside. Okay, it's just like salt, but it's magnesium sulfate. So you may be wondering, what is this? This is our control experiment. We will using room water. So we're gonna test. See, no changes from the purple color. So okay, wait. Okay, this is our lemon juice we were going to be use. So let's start. So we're gonna put the lemon juice inside. Yep. As you can see, the color has changed into bright red. Wow, what an amazing sight from here. So okay, so the water changes into red or pinkish like that. So here is the magnesium sulfate solution. We're gonna pour inside. Stir it well. Okay, not a big difference, but as you can see, it becomes more purplish. So it changes, it increased the blue color of the previous purple. So we can now know that acid we use in this experiment is lemon juice, will change it to reddish color, while if you use alkali or magnesium sulfate we will be using here, it will change it to bluish color. So that's all. we may change the manual sulfate using a toothpaste, so you can know the big difference. So hold up. So here's the new solution we're gonna use, which is the same red cabbage, but a new one. The other one has been wasted into the sink. So okay, instead of using a toothpaste, we're gonna use a Clorox. So testing it in 1, 2, 3. Okay, the moment of truth. Wow, the color. It's become a darker purple. Wow. So here's the difference. I will show you now. So the acid will make it more brighter. As you can see, brighter color. This is the controlled experiment, and here's the alkali. So I think we have proved our experiment, which is red cabbage can be used as a substitute for litmus paper or indicator for pH levels. So remember, after doing such experiment, we must throw out the waste in a sink, because it is a solution or water. So that's the end of our experiment. Bye bye. Guys, so today we're gonna do an experiment. What is the experiment? So eventually we're gonna use a vinegar and a salt. So that's a hint. Okay, I'm gonna straightforward to you guys. Our experiment is cleaning our coin. So this coin is made of copper. So the dullness of this coin is because of the copper oxide that is formed on the surface of this coin. So I already made a vinegar and salt solution. I have been mixing it until it fully dissolves. So here goes nothing. Okay, the coin. This is a one penny, I guess. So I'm going to put it only half of the coin inside this solution so we can know the difference. Why this will work? Because vinegar is acidic, so the acid will eventually dissolve the copper oxide on the surface of the coin. Okay, now we just wait. Okay, hi guys. So it been like 20 seconds or 15 seconds like that. I have take out the coin from this solution. So now you can see the difference. Wow, what a big difference we can see. The dullness before we see this is now only half, because half of it has been soaked with vinegar and salt solution. So we can see the metal oxide has been dissolved. So wow, clean and furbished. So I think This proves that vinegar, which is acidic, can dissolve the metal oxides from a coin. So don't forget to waste this, throw this solution inside a sink, because it is a solution, so it will eventually drain down. Okay, that's all from me. Thank you. Bye bye.